Okay, I'd like to welcome you all back to my personal classroom. Today we're going to actually take up a question that's in your textbook just for a little reinforcement into this mole-to-mole stoichiometry. And the question we're going to look at is number 9 on page 320. And to make life simple for all of us, I've copied out the bulk of the question, but I've left some answers out. So in this question, we've got magnesium nitride reacts with 6 moles of water to produce 3 moles of magnesium hydroxide and 2 moles of ammonia. So like I said before, the balanced equation actually tells us what the mole ratios are in terms of reactants and products. So that's all old news. You should get that fairly clearly. So on the equation line, I just reiterated that. We've got 1 mole underneath this reactant, 6 moles underneath this reactant, 3 moles here, and 2 here. And just in case you missed the previous video, moles are not conserved. You'll notice that 1 plus 6 is not equal to 2 plus 3. That's okay. It's grams that are conserved during chemical reactions. Now, in experiment A, question A, you'll notice that they're saying how many moles of magnesium nitride are required to produce 1.5 moles of ammonia. So I put the 1.5 over here. Well, this question is actually more about just simple ratios than it is about chemistry. That's the truth. And without a calculator, you can actually solve it. But let's talk it through. So it makes sense that if we have 1 mole of magnesium nitride and that produces twice as many moles of ammonia, then we would expect this number here to be twice as large as the moles of this reactant that we started with. So lo and behold, it's this simple. 0.75 moles of magnesium nitride would be required to produce 1.5 moles of ammonia. Okay? Let's move on to B. So in B, they're giving you 1.5 moles of ammonia again, and they're saying how many moles of water are required to produce that. So we're not really interested in magnesium nitride. That's why there's a big blank right here. The blank is underneath the water, and we're filling in the 1.5 moles under the ammonia. And again, look at your ratios. It's clear that 6 moles of water are required to produce 2 moles of ammonia. This number is 3 times as big as this number. And again, mental math. You don't have to use a calculator. So you can pretty well figure this out because this number is 1/3 or 2/6 the size of what we need over here. So in your head, 1.5 times 3 is 4.5 moles of water. And that's all there is to that. Now, in part C, maybe you have to use a calculator. They've made the numbers a little bit less round or easy to come up with. But again, it's very simple. All we have to do is some simple ratio work. So in question C, question says how many moles of magnesium nitride are required to completely react with 0.25 moles of water. Well, this is a ratio of 1 to 6. So in your head, hopefully you're saying to yourself, I need 1/6 as many moles of this stuff as this stuff. So at the end of the day, that's what we put in. 1/6 times 0.25 ends up being about 0.042 moles of magnesium nitride. And the calculator can do that for you. So that's all there is to it with the mole-to-mole calculation. It's that easy. Hopefully that helped. Like I said, my next video series will start looking at involving grams more often than moles. But we'll be using moles all the way through because it's such a central part of this unit. All right, we'll see you next time. Take care of yourselves and remember to social distance.